Good morning, grade 8s, or good afternoon if you're watching it in the afternoon. Today we're going to continue on with graphing functions, especially linear functions. And so previously you've learned how to graph this before, but today I'm going to teach you a technique that will save you a lot of time, and also it will be a lot easier in graphing these functions. But before we get started, let's look at this example over here. A fabric shop sells a certain fabric for $2 per square feet, and there is also a fixed cost of $3 no matter how much of the fabric you get. And so how can we represent the cost of the fabric in a graph? Now, this is actually a linear function. We can actually represent this situation by the function y is equal to 2x plus 3. Now, why is it 2x plus 3? Because it is $2 per square feet. And so if x is the square feet, the amount of square feet that I get, and then y is the cost. So y will be the cost, and then x will be the amount of fabric. And then this will be the $2 will be the rate. The rate of the fabric. And then the 3 is actually the fixed cost. And so this function represents the situation y equals to 2x plus 3. And so the cost will be $2 times the amount of square feet that you get plus $3 of the fixed cost. How can we represent this function in a graph? Now, traditionally, let me put it over here perhaps. So traditionally, what you would probably do is you would draw an output table. So for example, you would input you would put in numbers. For example, you would do your x, y table over here like that. And then you would put in 0, 1, 2, 3 as an example. And then you would put the numbers into the function. So 0, when x is 0, then 2 times 0 plus 3 will be 3. Y will be 3. When x is 1, then y will be 2 times 1, which is 2, plus 3, which is 5. And then 2 times 2 is 4, plus 3 is 7. And then you can start to see the pattern, 3, 5, 7, 9. And then what you would do is you would then graph your function by drawing a graph like this. Let me see if I can draw this nicely over here. And then we have x, we have our y, we have our x, and then, oops. And so this is y, this is x, and then the middle is 0. Let's say that this is 1, this is 2, this is 3. And then for our y, let's just start with, because we have to go all the way up to 9, let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, perfect. So I know that I am going, so 1, 2, 3, 4, 5, 6, 7, 8, and I ran out of space. I need to go up a little bit. Whoops. 9 over there. That's why. And then what you would do is you would plot these points. So 0 at 3, 1 will be 5, 2 will be 7 over here, and 3 will be 9. And then after you have plot the points, what you would do traditionally is you would then get your ruler, and then you will then connect the dots like this. And so that will be your graph. That's what you would usually do traditionally. Now, what I want us to do today is we're going to explore how the function change would change, how the graph would change according to how the function will change. And so let's start off with a few more graphs a few more functions. I'm going to start off with some simple ones. So we're going to do a mini investigation. Well, I'm going to do a mini investigation over here for you to see. And I want you guys to focus, and I want you guys to think about how the function changes, how it would affect the graph. So mini investigation on linear functions. Now, I forgot to mention what is the meaning of linear functions. So I'm going to do that first. Let me just quickly put this at the bottom. And then I want to quickly talk about what is the meaning of a linear function. So the meaning of linear means, linear actually comes from the Latin word of linea, which means line. Actually, it just means line. And so linear means arranged in a straight line. That's actually the meaning of linear. And so when we put linear together with function, linear function means a graph of a straight line. Or I should say a function in which the graph would result in a straight line. Let me just put it in a better way. So it is a function in which the graph results in a straight line. And so if we look at the above example, y equals to 2x plus 3, that is a linear function because the graph, it is exactly a straight line. It doesn't bend, it doesn't curve, and so on. So that will be a linear function. Okay, so that's linear function. So let's do some investigations on linear functions. I'm going to start off with a very simple example of y is equal to x. Very simple. And so whatever value we put in x, y would just be the same. So for example, if we do our xy table like this, xy, if x takes 0, y would take 0. If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is also 3. And so what would this function look like? So if I'm going to quickly sketch out what this function would look like, we have 0 in the middle, that's going to be 0, 0. And then we have 1, 2, 3, 1, 2, 3. Make sure you label your graphs, x and y. And then we can also do -1, -2, -3, and -1, -2, and -3. 0, 0, we have 1, 1, we have 2, 2, we have 3, 3. It is a straight line. And so what we can do is we can actually plot a line that goes straight down like this. That is a straight line graph. And so this is a linear function. That is when y is equal to x. Now, I'm going to change up this function a little bit. And let's just say this time I have y equals to x plus 1 instead. And so every single value that x takes, y would be 1 more than it. So if I'm going to do our y table over here again, if x is 0, y is going to be 1 more than that. That's going to be 1. If x is 1, y is going to be 1 more than that. That's going to be 2. If x is 2, y is going to be 1 more than that. That's 3. And if x is 3, y is going to be 1 more than that. That's going to be 4. And so what would this graph actually look like? Now, let's go ahead and plot it out. I'm out of space. Like this. Ooh, like that. So we have 0, 1, 2, 3. We have 0, 1, 2, 3, 4. And so when x is 0, y is equal to 1. When x is 1, y is equal to 2. When x is 2, y is equal to 3. And x is 3, y is equal to 4. And then our graph would look somewhat like this. Now, it looks very, very similar to the above graph. Very similar. The only thing that is different is that instead of the line passing through at 0 over here, at 0, 0, the line passes through our y at 1. That is the only difference over here. Now let's further on continuing by looking at a similar example again. So this time y is equal to x, but I'm going to change it to -2 this time. That means that for every x value that we put in, y is going to be 2 less than that. So again, I'm going to do my xy table over here, and let's say x is 0, then y will be 2 less than that, that's -2. When x is 1, y is 2 less than that, that's -1. When x is 2, y is 2 less than that, that's 0. And when x is 3, y is 2 less than that, which is 1. And then let's go ahead and plot it out in a graph. And this time, let's see what it looks like. So we have 0 in the middle. We have 1, 2, 3. That's x, and that's y. Don't forget to label your graphs. And then we have 1, and then 2, but we have -1, -2, -3, and so on. And so when x is 0, y will be -2. When x is 1, y is equal to -1 over here. And when x is 2, y is equal to 0. When x is 3, y is equal to 1. And we can see our x's are still in a straight line, but then this time it's down here like this. And you can see the 3 graphs looks almost identical. They look almost identical, but the only thing that changes is that they pass through our y-axis at different points. Now I want you to look at these points over here. This 0 point is because of there's no constant being added, plus 0 over here. And then this 1 over here corresponds to our +1 over here. And of course, our y is -2 corresponds to our -2 over here. And so our +0, +1, our -2 actually affects where the line would cross over our y-axis. In fact, in grade 9, you would actually learn that this is called the intercept. But I'm going to teach us a little bit in advance. This is called the intercept. The y-intercept. Now we're going to look at something slightly different. Okay. The first part, you can also add a word called the intercept, because this is all to do with the intercept. So whatever we plus at the end or minus at the end, that affects where the graph would cross through the y-axis. That is the vertical axis over there. Now, let's now look at another way that the graph can change. Now, this time, we're going to have y is equal to x again. I'm going to start that out. Without doing the table, I'm just going to quickly draw out what this would look like. So this would actually look like this, where 1, 2, 3, we have 1, 2, 3. That's our straight line over here. And so that's y equals to x. And then the next one we want to look at is y is equal to 2x. And so what does this actually look like? So if I have my x and y table over here, when x is equal to 0, y is also equal to 0. When x is equal to 1, y is 2 times of 1, which will be 2. When x is equal to 2, y will be 2 times 2, which is 4. When x is equal to 3, y will be 2 times 3, which is 6. And so let's quickly draw what this would look like in a graph. And so we have 0, 0, 1, 2, 3. We have 1, 2, 3, 4, 5, 6. I barely have enough space in my graph over here. And so 0 at 0, that's my x cross over there. 1 will be at 2, 2 will be at 4, 3 will be at 6. And then our graph would look like this. So that will be our graph of y equals to 2x. And so now let's look at another one. Let's say that y is equal to 3x, for example. And then again, let's draw our x, y table over here. When x is 0, y is 3 times 0, which is still 0. When x is 1, y is 3 times of 1, which is 3. When x is 2, y is 3 times 2, which is 6. And when x is 3, y is 3 times 3, which is 9. And so later on, when I draw the graph, make sure I do have enough space for my y-axis. And so we have our, I'm going to use a little bit more space this time, like this. And so 0, 0 in the middle, we have 1, 2, 3, that's our x, and then this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so when x is 0, y is 0, when x is 1, y is 3, when x is 2, y is 6, when x is 3, y is 9. And so we can start to see a pattern that it crosses through like this. Now, what is the difference between these three graphs that we see? Now, the first graph, you can see for every one box that it goes up over here, it goes across, it goes up 1. That is this. So for every one box that it goes across, it goes up 1. And so it's not very steep. And for y equals to 2x, for every one box, it goes up 2 because it's 2 of x. And so here, for every one box for y equals to 3x, it goes up 3 boxes. So actually, there is a word for this. This is actually called the slope. Or it is the coefficient of x is actually called the slope. And so the slope will be how steep the line will be. And so the bigger the number, the steeper it will be. Now, for the very, very last example, I'm not going to do too much, let's look at y is equal to negative of x this time. That means whatever x value we put in, y would be the negative of that one. What would that actually look like in a graph? And so let's quickly do our table. So we have our x, we have our y, and then if x is 0, y is negative 0, which is 0. If x is 1, y will be negative 1. If x is 2, y will be negative 2. And x is 3, y will be negative of 3. Which means that if we now plot our graph, what will it look like? So if x is 1, 2, and 3, negative 1, negative 2, and negative 3, then that is our y, this is our x. So 1, 0, 0, we have 1, negative 1, we have 2, negative 2, we have 3, negative 3. Our line actually is going the other way round. So if there is a negative, our line would go downwards, and if our x is positive, then it would go upwards. Usually we would say that these lines are going upwards. So the first three examples of y equals to x, 2x, and 3x, these are upward graphs. And then if we have y is negative x, we call this a downwards graph because it is negative. And of course, because that's negative 1 times x, that means that for every one value that we go across, we would go 1 down as well. So keep that in mind. And so how would I be able to quickly graph out a graph without drawing our tables, especially if we have 2x plus 3 or maybe 3x minus 1. And so let's look at some final examples. So examples, we want to graph the following linear functions. So that for A, let's do y is equal to 3x. Let's start with a simple one. Let's just do 2x minus 1. And then B, let's do one more. Y is equal to 3x minus 2. So we have two functions over here. How do we do that? So without even drawing a table, I'm first going to draw my xy axis like this. So we have our x, we have our y, and that's going to be 0, 1, 2, 3, 4, 1, 2, 3, 4. And so the meaning of 2x, now remember at the very beginning, we started off with the intercept, and whatever that plus or minus number will be, that will be where it crosses through the y-axis. And so if we look at our function over here, we have a minus 1, which means that our line is going to pass through negative 1 over here. So it will pass through the negative 1. And so we're going to start off over here, negative 1. And then 2x means that for every 1 that we go across, we would go up 2, which means that it will be starting from -1. We will go 1 across. Let me use the green line to represent this. 1 across and 2 up, like this. 1 across and 2 up, like this. Which means that my points will be at -1, 1, 1, and 2, 3, without even needing to calculate, without needing to draw a table. And then I can just draw a line that goes 1 across and 2 up, passing through that -1, and this will be my graph of y equals to 2x minus 1. Then for b over here, let me quickly draw my graph. So we have 0 in the middle, 1, 2, 3, and then we have 1, 2, 3, 4, 5, -1, -2, -3, and -1, -2, -3. And so if we have our x, y axis like this, we start off with -2 over here, which will be at -2 over here. So it will pass through our -2. And then the 3 means that for every 1 across, we will go up 3. 1 across, we will go up 3. And so we will have we have 0, -2. We have 1, 1 over here. And then we have 2, 4 over here. And so our line would actually look like this. So we just go 1 across and 3 up, 1 across and 3 up, and so on. Okay, so that is actually how we can very quickly and easily graph linear functions. And so we're not going to, okay, so I'm not going to give you too much homework, but I want you to graph the following linear functions first. So for your homework, I would say, so I'm not going to set the textbook questions, but instead I want you to do the following, try your best to graph the following functions. So, but if you prefer to use the table method where you just draw the 3 dots first and then you graph it out, feel free to do that. You can still use that method, but I want you to try to do with the new way. And so let's say the first one is y is equal to x minus 2. Just graph this one. B, let's do y is equal to 2x plus 1. And then for C, let's do y is equal to, this time is negative x, and then let's do plus 2. And then for D, let's do y is equal to negative of 3x plus 5. Now, remember, I just want to keep a note. If it is negative over here, it means that the slope is going downwards, downward slope. Okay, so that's the negative sign. And so which means that for 1 across, if it's negative x, it will be 1 across and 1 down. If it's negative 3x, it will be 1 across and 3 down. So just quickly going to remind you, this means 1 across and 3 down. And then this will be 1 across and 1 down. That's what it means. So I want you to plot these 4 graphs for your homework. Make sure you use a ruler, and you can use grid paper if you have. If you don't have grid paper, then just normal white paper is fine, or lined paper is fine. Just try your best to be as neat as possible. That is it for today's lesson, and I will see you guys tomorrow.